Have you ever wondered why the weather reports are sometimes inaccurate and why the weather can only be predicted for 7 days? To understand this, let's go back to the 1960s.
Edward Lorenz, a mathematician and a meteorologist working at MIT, had built a weather simulator. During these weather simulations, a small rounding off error led to a completely different weather forecast. Lorenz realized that tiny changes in the initial conditions of his input resulted in a drastic change of the outcome. This rounding off error helped Lorenz discover the butterfly effect. What is the butterfly effect? The term butterfly effect was coined from an analogy which states that a butterfly flapping its wings in Brazil can cause a tornado in Texas.
The butterfly effect states that the outcome of what happens in a system is highly dependent and is extremely sensitive to initial conditions. In other words, small differences in the input can result in large differences in the outcome over time.
It is one of the necessary conditions for a system to be termed chaotic. The butterfly effect laid down the foundation for the chaos theory. Now, what do I mean by chaotic systems and what is the chaos theory? Chaotic systems are systems which are highly sensitive to small differences in their initial conditions. Chaos occurs even though such systems are deterministic. This means that their future behavior is determined by their initial conditions with no random elements involved. Even though a system may be predictable in the short term, chaos can make it impossible to accurately predict the behavior past a certain point in time. But these systems also have a set of underlying patterns to them, and the study of such systems is known as a chaos theory. Now let us consider an example of a simple chaotic system, which is the double pendulum. When you swing the double pendulum, in the start, the motion and the trajectory of the second pendulum is quite predictable. However, over time, the motion in the direction in which the second pendulum travels is almost unpredictable. In this case, a double pendulum is swinging with an angle of 45 degrees. Let us change the angle to 50 degrees and let's compare the change in the swing pattern. Comparing the results, we see that the pattern of the second pendulum is completely different with a minor change in the angle. Therefore, the double pendulum undergoes a chaotic motion and shows a sensitive dependence on initial conditions.
Chaos theory also helps us model and explain several complex systems such as the pandemics, the economy, the financial markets, and even the weather. Meteorologists now do what is called ensemble forecasting. Instead of making one single weather forecast, a set of weather forecasts with different initial conditions is produced. The current pandemic reminds us that the world is often chaotic as we deal with many uncertainties. While we may not be able to predict the long-term outcomes, chaos theory helps us to plan and be prepared for multiple possible outcomes. Thank you for watching.